Okay, Algebra 1, we are going to start in again. Here on Exponents, I know we worked on this the other day, but I want you to watch this video. We'll go through a few more examples. That way you can see them, and then the ones on your handout might make a little bit more sense. So maybe refresh your memory here. First, some basics that we went over the other day. We're going to talk about base, power, and an exponent when we're dealing with these things. So our base is what we will be uh, multiplying a certain number of times. So that's like what the 4 is here. That's what we will multiply by itself over and over again. And what will tell us how many times we do that here is, of course, our exponent up here. Now, those two as a whole are what we refer to as the power. Okay, so the base and the exponent of that expression is called the power, and they go together. So as we look at these, and we wanted to write those as a power, we could just look at everything that repeats itself. It's all multiplication. So in an instance like this, we've got 2 3's, we've got 3 x's, we've got 4 y's. Well, those would be our exponents on each one of those bases. Over here, we've got 4 7's, 3 a's, 2 c's, 3 b's down here. We would write those accordingly. Okay, hopefully we don't have any problems with those. You can look here at these two, and let's decide who is correct. Hopefully, we actually did an example on the board the other day that indicated that these were in fact different from one another, right? Here, what is being raised to the 6th power, and here, what is being raised to the 6th power? Well, over here is just the 3. That negative is going to remain no matter what that is. Out here, you're actually taking a negative 3 and multiplying it by itself 6 times. So which one is correct? Well, here I don't have 6 3's. I have 6 negative 3's, and I'm not handling that appropriately here. Therefore, Devin would be the one who is correct, because he's the one who took the negative 3 times itself 6 times. Okay. So I'm not going to go through all of these examples. I think we should have a good hold on that. We simply count things up, how many times they are multiplied by itself, and that would be our exponent for that particular base. Okay? One thing we would look at right here, we'll go over this one. Negative 4 to the 5th power. Remember, what is being multiplied 5 times here? Well, it's just the 4. I know my answer is going to be negative because it remains here. It is not involved with this exponent. So I'm going to have 4 to the 5th power, and then the answer is going to be a negative. So we're right there. Okay? I'll move along here. The 0 exponent, I'm not going to spend a whole lot of time on that because we did the other day in class, but as I showed you the proof of that using the quotient rule, here's another indicator of what something to the 0 power is, why it is always equal to 1.
Let's use a table to find the value of 5 to the 0 power. We know 5 to the 4th power is 625. 5 cubed is 125. 5 squared is 25. And 5 to the 1st power is 5. Now look at the pattern. Notice that as the powers decrease, each number is divided by 5. So if we divide again by 5, we get 1. That means 5 to the 0 power must be 1.
And that goes along with the quotient rule of what we talked about the other day, which this all makes sense because as we increase our exponent, that means we're multiplying by another 5, right? So as we would decrease it, we would do the inverse of that and be dividing by another 5. Okay, so that is why anything to the 0 power is equal to 1. If we look real quick down here, that would be 1, that would be 1, that would be 1. I know this would be 1 as well. Okay, but I've got a little problem here. What does that 0 exponent apply to? Well, it only applies to b. Therefore, only that portion of it would be equal to 1, and I would be left with a 3a. Okay? Let's hear their explanation.
But why isn't 3ab to the 0 equal to 1?
Look carefully at what is being raised to the 0 power. Without parentheses, the 0 power only applies to base b. So only b to the 0 power is equal to 1. Therefore, the expression simplifies to 3a.
Okay, so the location and if parentheses are present or not are going to have a big impact, obviously, on our final answers here. Okay. All right. I think I'm going to skip down to our negative exponents here, and we're going to look at a table here to, we talked about how negative exponents, if they're negative and they're in the numerator, we can flip them to the denominator and make them positive, right? Another way to look at these is I can continue that pattern that I looked at to figure out what the 0 power is. And I just was dividing by 5 each time, right? Which would mean that this one should be, if I divide 1 by 5, should be 1/5. And then if I divide that, whoops, not sure what happened there. There we go. And then if I divide that by 5, I'd have 1/25. I divide that by 5, I would have 1/125. And if I divide that by 5, I would have 1/625. Okay? Check those. Alright? So that just solidifies that if I am looking to turn these positive, I can change their location from numerator to denominator and make them positive. Alright. So that's where this negative exponent property comes in. Okay? Let's see. And down here, if we're going to simplify using positive exponents, then the first thing I need to do is look at them. I don't have a like base, so I cannot combine these, right? So I'm simply going to have to change their location. Each base is going to go into the denominator. So I'm going to have 1 over, and then I would have, whoops, then I would have 4 squared times well, times, whoops, well, this isn't working. Anyway, I've messed this whole thing up. Anyway, we would have 1 over 4 squared m to the 11th power, right? Because we just changed their location. Okay, let's listen to this and then we'll move on.
How do we simplify an expression if the negative exponent is in the denominator?
That's a good question. Let's look at the expression 1 over a to the negative 3 power. First, we can write this expression using division. Now we can write a to the negative 3 power using positive exponents. Next, let's change division to multiplication of the reciprocal. And finally simplify. So in general, 1 over a to the negative n is equal to a to the n.
Okay, so that they showed that mathematically here. We want to change the location of it effectively. So just like when we move something from the numerator to the denominator, we can simply move it back from the denominator if it's negative down there to the numerator and make it positive. Okay, product of powers. I think we've got a pretty good handle on that. The thing to make sure that we have is, in order to follow this rule and simply add the exponents, I must have a like base here. Okay, so here I've got a like base. I'm simply going to add those exponents up. Okay, so I would get x to the 75th power right there. Okay, adding these up, I would have a 14 plus a negative 6, or minus 6, which would give me 8, and then 8 minus another 2 would give me 6. So I would have x to the 6th power there. Alright. We'll look real quick at these. In order for my answer to be d to the 6th power here, what do I have to add to 3? Well, that would mean the exponent right here would also have to be 3, because then I would get 6. My answer here doesn't have any e in it, so that means my exponent would have had to have been 0. Well, what does the exponent of e need to be if I'm going to get a 0? Well, it would need to be 2. And for me to end up with f to the 5th power, I have 1 here. I would need to have 4 in the other one. Check that. Man, wonderful. Aren't we wonderful? Okay. Let's look at something that not only involves a variable in the base, but also involves some coefficients out here. And we looked at an example the other day, but an 8, a negative 2, and a 5. So the first thing we need to look at here is if the exponents don't apply, and I don't have any exponents outside these parentheses. Okay, so these exponents here don't apply to the coefficients. So I would simply take 8 times negative 2 times 5. That's my first step to get the coefficient of my answer. And then I'm going to look at all of the base u. I've got a u here and a u here, so I would add those exponents. Got that. Then I look at my base v's. I've got a v there and a v there. Add those, and that is my, not quite my final answer, because then I've got a negative exponent here, and we know in order to make it positive, I change it to the denominator. So I've got everything I've got up here, and then I just move that v to the negative 2, change its location, make it positive. Now don't get carried away. and think that you can take this negative 80 and put it down here and make it 80. That's only a rule that applies to exponents. Okay? Alright. Hopefully walking through that example straightened out any confusion on that. Here's an application area of this rectangle. As we know, to find the area, we take the base times the height, or length times width, of a rectangle. Therefore, if I took 2x squared times 3x, multiply my coefficients first, that would be 6. X squared times x would be x cubed, and I'm good there. Alright, power of a power. Quite simply, if I raise some power to another exponent, remember that's like going up a level. This would be like taking x cubed times x cubed. So that's why we now, instead of adding, we multiply these, right? Because we know exponents are simply repeated multiplication. Just like multiplication is repeated addition, exponents or powers are repeated multiplication. Alright. So here it is using the power of a power. Now we're simply going to multiply those exponents, simplify. Okay, same thing, writing it out long way or the short way here. So I'm not going to go through all these. This would be x to the 8th. This would be c to the 12th, because a negative times a negative is a positive. Okay. Now, if we've got a power of what is called a product, because these are being multiplied together, let's show the steps for this. So I've got this problem right here. I've got x to the 5th times y to the 4th raised to the 3rd power. Well, I can't combine these because they're an unlike base. Therefore, I need to apply this power separately. Apply this power to the x to the 5th. And to the y to the 4th, I'll apply it separately. Then I know that I've got a power to a power. So what do I do with those exponents? I will multiply them and then write my final answer. Okay. So what did they do incorrectly down here? I've got a 2xb to the 4th. What should this 6 apply to? First off, does it apply to just the 2 or just the x or just the b? No, it should apply to everything. Okay. So they actually did a couple things incorrectly. They didn't apply the 6 to any of the other pieces. We should have 2 to the 6th power, x to the 6th power. But then, what they did with the b, they didn't do it correctly either, did they? Is what should I do with this 4 and 6? I shouldn't add it, I should multiply it. Okay, so my final answer should have been 2 to the 6th power, x to the 6th power, b to the 24th power. Alright. So hopefully that helps on that. We'll go through a couple more things real quick, and then I'll wrap up. We'll watch this video, and then we will move on. So the quotient rule, I think we all had a fairly good handle on the quotient rule. Remember that to use that quotient rule, I'm going to skip right down to it. we simply subtract, right? Okay, so let's look at what they do here. We could expand it all like I did in class and then simplify the ones that simplify. I'm left with x squared on the top. Same thing here. I could expand it all, simplify the two x's, simplify the two y's, be left with an x cubed and a y. Or, as we know, we could have simply subtracted those exponents as our quotient of powers property is written. Okay, so if we're going to use positive exponents, I can look at this and know that I would be able to simplify out 6 of these b's. That'd be left there. Or I could have also looked at that, b to the 6 minus 8. 6 minus 8 would be negative 2, but that would have been in the numerator. I can change it to the denominator and be positive. Okay? So this quotient rule. Now the power of a quotient property is the same thing as the power of a product property. Just remember that this exponent out here applies to everything inside. So let's watch this. I'm going to square everything in there. Square the 3, square the m to the 6th, square the 5. Okay, so square that 3 to 9. M to the 6th power raised to the 2 power, and multiply those, and then 5 squared is there. And let's watch one with a negative exponent. Raise each one to the negative 3. Then if I am writing my final answer, I will flip those, right? Because this 7 needs to go down here to have a positive exponent. 2 needs to go up here to have a positive exponent. And then I just simplify there. Alright. So a key point here, if you've got a quotient raised to a negative property, it's the same thing as the reciprocal of that quotient raised to the positive exponent. Okay? Meaning this one right here, for example, would be the u squared would be in the numerator, and the t to the 4th would be in the denominator. Okay? So, u squared, and that t to the 4th would be in the denominator. Alright. So you've got this summary table in your packet of information. The last thing I want to go through is solving these, and we'll look at solving the basic ones. Take just a few minutes here. Let's see here. We went over an example in class, but let's look. I want to solve this. If I've got a like base and I know I want these to be equal, then what also has to be equal? If a like base to different exponents, or differently written exponents, has to be the same thing, then these exponents have to end up being equal to one another. Okay, so listen. The first thing we do if we have a like base, we set those exponents equal. And then I'm going to solve for the x. I would move that, well, they moved the 3x over here. And then I divide by a negative 2 and I get x equals 2. Okay? So here, for instance, you would take the x plus 6, set it equal to 14. You would end up understanding that x equals 8. Okay? Alright. if we look at a little bit more complicated one, these are separate over here. But if I combine these, this would be 2 to the 2 plus x power. Okay? So that would be my first step in solving this. The left side of this equation can be simplified to 2 to the 2 plus x power. Okay? And now I could solve for x. I would set 2 plus x equal to 3x minus 4 and solve for x. Here, my first step would be to get this base of 6 in the numerator. So this would be 6 to the negative f power. And then I could set negative f equal to 8. Okay. So I don't want to dwell on this. I think that's pretty much all I want to cover with you. When you come into, or we will continue working on these 4-1 exponents and wrap those up today.